Hi everyone, I just want to walk through some of the vector operations that you can do with polygons that we went over in the previous page before moving on to the rest of this module. So here I have some narcotics data for the city of Buffalo. It's some of the similar data that we used in the previous demo. And I have a base map up just to give you a little context of where Buffalo sits. So it's on the shores of Lake Erie, and across that lake is Canada. Now I'm going to turn off the base map and I'm going to turn on the Buffalo block groups, so the census block groups here. So now we have the block groups, and on top of that we have the narcotics points, so points where an arrest was made for drugs. Now, in this particular instance, we have point data, but we want to analyze it as a polygon. So we want to kind of attach it to the neighborhoods or the block groups and then analyze those polygons instead of analyzing the points directly. So the first thing that we have to do is we have to actually get those point values into the polygons. And the easiest way to do this is through a spatial join. So if we right click on the block groups here and we go to joins and relates, and then over to join, click on join, and it brings up the window for joining data. Now, instead of joining attributes from a table, so making a kind of a table-to-table join, we want to hit the drop down and join data from another layer based on the spatial location. Now, what this is going to do is it's going to take where the points are located, and it's basically going to kind of stick them to the block group in which they're located. So the layer to join to block groups is going to be narcotics. And then in step 2, it says we're joining points to polygons. So we can choose to choose a way to actually summarize those points. Now, all we care about in this analysis is how many crimes happen within each block group. So I'm going to click sum, but for other types of analyses, you might choose to click some of the other options here. And then the last thing you need to do down here is choose where you're going to save the result to the join. So put it in a folder where you're going to be able to find it and name it something that you will know what that file is later on. Then hit OK. All right, so you can see here a new data layer has been added to the layers list over here called spatial join. So I'm going to turn off the block groups, leave the spatial join on, and if I open the attribute for that, we can see over here in the count field is a count for the number of narcotics arrests that happen in each of the block groups. So if I go over to spatial join and I go down to properties, we can symbolize the polygons now according to the number of narcotics arrests within each polygon. So go to symbology, go to categories. Actually, we're going to do quantities, graduated colors, and for the value, choose that count. Hit apply. And you can see here it's been symbolized according to greater amounts of crime arrests are in the red and lower amounts are in the blue. Now this is quite a contrasting color palette, so I'm going to change it to something a little bit more subtle to work with here. Let's see. Something like that. So if we put the points on top of the polygon and we just toggle on and off, you can see that where there are high concentrations of points, we also have the darker shades of orange, signifying more crimes happened within that block group. But for our analysis, we want to stick with the polygon data. So I'm going to turn off the narcotics points and just leave the polygon layer here. So one question we might want to ask is whether drug arrests are clustered in space. So whether we have pockets of the city where we have higher numbers of drug arrests compared to other areas of the city where we maybe don't have any or have lower numbers. And if we just visually look at this map, we can sort of see some patterns starting to appear. So we have higher clusters over here on the west side. We have some darker colors over here on the east side. Up here kind of on the northwest side of the city, we have some darker colors. And we could make a qualitative statement that we think that there are some areas with higher amounts of crime in the city. But we can also use statistics to quantitatively support whether the patterns are clustered or random or maybe dispersed throughout the city. So the first statistic we're going to use is called Moran's I. Moran's I is a global statistic for measuring spatial autocorrelation. So when the term global is used in regards to statistics, it means that the statistic analyzes the entire set of data together, and it's going to return a single value describing the pattern of the features. In this case, Moran's I measures global spatial autocorrelation based on our polygon locations and the feature attributes within that polygon. So in this case, the number of drug arrests that happened within that block group. So to find the Moran's I statistic, we're going to go up here into the search, type Moran's I, and spatial autocorrelation, global Moran's I is the tool that we want. So the input feature class, again, we're working with polygons here. So we want to put in our polygon that has the narcotics data joined to it. The input field is going to be that count, which is the count of the number of crimes that happened within each polygon. Now there's a few choices here that you have to make. The first is how you're going to conceptualize your spatial relationships. There's a whole bunch of options here. We're not going to go through all of them, but if you open up the help here, over here on the side, you can see the description of each of the different types. For today, we're going to use just a fixed distance band. So that means basically it's going to look for neighbors within a fixed distance, and we're going to tell the computer what that distance is going to be. It's going to be measured in Euclidean distance, and then the distance we're going to give it is going to be, we'll just give it maybe 1,000 for now, and we'll give it 2,500. So 2,500 feet because our data are projected in a coordinate system that uses feet. So we hit OK. So when the tool is done running, you won't see anything added over here to the layers table of contents because it didn't create a new layer. Where you want to go to see the results is up in the geoprocessing dropdown and then hit the results window here. The results window, whoops, let's go recenter that. You may need to expand this to actually read the full column here. But basically, it's giving us the spatial autocorrelation Moran's I results. The index is the actual I value. You learned how to calculate this in the page before. And the I value here is 0.3. Now, the Z-score is 12.2, and that gives you an indication of how significant that that index score, that I score is of 0.3, and the p-value of 0. So basically, together what these numbers are saying is the 0.3 is greater than 0. It's telling you that the data are clustered in space. 1 would be the highest, that would be 100% clustered. -1 would be 100% dispersed. And so a value of 0.3 is in the positive side, so we do see clustering. And the z-score and the p-value basically tell us how significant that is. So a p-value of 0 tells us that, yes, those results are significant. Or in other words, we wouldn't expect to find that level of clustering if the points were just randomly placed in space. So basically what Moran's I is telling us is that we have clustering in our data, and that gives us the indication that we can then start to explore where that clustering is happening and why we might be seeing certain patterns or certain crimes happening in one area and not another. So Moran's I is really useful for giving us an indication of whether or not features are clustered, but it doesn't give us any information on where that clustering might be occurring. To answer that question, we're going to use a technique or a statistic called the GEDIS-ORD GI star statistic. So the GI star statistic gives us an indication of where features are clustered with either high or low values. So it's going to tell us where we have areas with lots of narcotics crime surrounded by other areas or block groups with lots of crime. But it's also going to tell us where we have areas with very little crime that are surrounded by other areas with very little crime. So to use this tool, we're going to go over into the search and just put in GEDIS-ORD. And the hotspot analysis, GEDIS-ORD GI star, is the one we want. So go ahead and open that up. Our input again is going to be the spatial join feature class, and our field is going to be that count. The output features, again, put it somewhere that you can find it, name it something representative. Again, we'll use a fixed distance band just like before of Euclidean distance. And in this case, we'll choose the same distance so we can keep our analyses comparable. We're not going to choose a self-potential field, and we're not going to put in our own weight matrix files. Those are a little bit more complicated on the statistics side of things, but they are options if you want to use them. So we're going to hit OK. Okay, so this time we did have a new layer added to the map. It's over here. It's called GIS Ord. The red areas are areas where we have hot spots of crime. So the brightest red values, the darkest red there, are areas where we have a 99% confidence that we have that the pattern that we're seeing there is significant. As we move kind of down in the red shades, our confidence levels decrease, but we still have hotspots of crime, statistically significant hotspots of crime. So you can see these three areas. We have one on the west side here, we've got one over on the east side, and we have one up here in the northwest. Those coincide with the patterns that we visually noted earlier, looking at just the color-coded polygons, but now we actually have a statistic that can quantitatively back up our findings. Now, similarly, in addition to the red areas, we also have some cold spots of crime. So these are areas where crime is not happening, where we have very low numbers of crimes surrounded by other areas with very low number of crimes. And again, these are statistically significant at a 99%, 95%, and 90% confidence. Now, a map such as this one produced through the GIS Ord statistic can be a good launching point for digging down and starting to figure out what processes might be at work that are causing these patterns. So what might be happening on the ground in these three areas where we see hot spots of crime that are leading to higher than normal levels of narcotics arrests. Similarly, we can look at what's happening in the other areas that are leading to very low levels of crime compared to the other areas of the city. So hopefully this demo gave you some ideas of how you can analyze polygon vector data, how to get point data into polygon form, and some tests that you can run to quantitatively assess clustering, patterns of clustering in your data.